Alright guys, the topic for today is kinetic energy. So does a moving ball have energy? And how do you know? So yes, it does have energy. An object in motion has energy because it is moving, and a moving mass can exert forces. So remember we talked a little bit about mechanical energy a few lectures ago, and it's just the movement of something. If something is moving, we have some mechanical energy there. And it can either be kinetic or potential. So how would you define potential energy? Remember, potential energy is stored energy. Usually, the higher we have an object, the more potential energy it has. It is stored, and it's there until it moves. So what do you think kinetic energy is? Well, kinetic energy is the energy of motion. It depends on the mass and the speed of that object. So the faster an object moves, the more kinetic energy it has. So the formula we use to represent kinetic energy is E equals 1/2 mv squared. So sometimes I like to write it as PE. And so potential energy is in joules. And mass will be in kilograms. And our speed is in meters per second. And so the kinetic energy is directly related to the square of the velocity. And that makes sense because velocity is squared in our formula. That means it increases exponentially, resulting in a curved graph. So the higher the velocity, the more kinetic energy. That makes sense. The more you're moving, the more kinetic energy. So what is the kinetic energy of a 4 kilogram mass moving at 3 meters per second? 3 meters per second is our velocity. So let's write our variables down first. So let's write our variables down. M is 4 kilograms. V, our speed, is 3 meters per second. What is our kinetic energy? Kinetic energy is 1/2 mv squared. Let me write that clear, mv squared. So m is 4, and then our velocity is squared. Do not forget to square velocity. So 3 squared is 9 times 4 times 1/2 is 18 joules of energy. So look at the formula for kinetic energy. What would happen to kinetic energy of an object if the mass doubled? So we have kinetic energy equals 1/2 mv squared. If mass is doubled, what happens to kinetic energy? So let's use ones. On the left side here, we start with the mass of 1 and velocity is 1. And we figure that with the calculation is 0.5. Now, if we double the mass, we find that kinetic energy is now 1. So that means it doubles. So when we increase mass by 2, our kinetic energy also changes by 2. It doubles. So now let's look at the formula for kinetic energy and what would happen to that energy if the velocity is doubled. Well, we find that it quadruples, and that makes sense. Velocity, if we square velocity here, that equals to 4, and times 1, still 4, and then times 1/2 will equal 2. So going from 0.5 to 2, that's quadruple the amount. So remember we have that exponential curve. As velocity increases, kinetic energy exponentially increases. So when a car stops, its kinetic energy of motion is completely converted into work done by the brakes. So work done is equal to the change in kinetic energy. So this brings about a new formula. So work done is equal to the change in kinetic energy. Change, remember, is represented by a triangle. Remember, we usually have final minus initial here. That means a change, and we call this the work energy theorem. So let's look into that a little bit. So the formula can be written in different ways. So don't let this bog you down. We're gonna break this down a little bit. So work is a change in kinetic energy. So kinetic energy, and remember I told you that change is final minus initial. So we write it like this: kinetic energy final minus kinetic energy initial. Or remember, kinetic energy is equal to 1/2 mv squared. So we have 1/2 mvf squared, that's our final velocity, minus 1/2 vi squared minus initial velocity. It's the same thing. Or we can do a little bit of algebra and grouping, and we could say it's 1/2 m times, and then group together our final velocity squared minus initial velocity squared. And so depending on the situation, some of these equations might be easier to use. So a car with a mass of 1,300 kilograms, so start writing your units down, is going straight ahead at a speed of 30 meters per second. That is our velocity. How much work is done to bring the car to a complete stop? So this is a work energy theorem, so let's work this out. Our initial velocity is 30 meters per second. If it comes to a complete stop, then our final velocity is 0 because it stopped and we're asking for work. So here work is a change in kinetic energy. And we can use this formula. So here we decided to use the formula. So let me rewrite this. We decided to use 1/2 m vf squared minus vi squared. So 1/2 m, which is 1,300 kilograms, plus our final velocity is 0, 0 squared is 0, minus 30 squared. So when we multiply all this together, we get work is equal to 585,000 joules. So we drop the negative because work is a scalar quantity. It does not have a direction. So a car with a mass of 1,200 kilograms, so start writing your units down, is traveling at a speed of 25 meters per second. That is our velocity, our initial velocity. How much work must be done to increase the speed of the car to 30 meters per second? So we're increasing it, so that's our final velocity. And so we're looking for work. We don't know what work is. So once we have our variables down here, we use the kinetic energy, work energy theorem equation. Again, this equation we use 1/2 m vf squared minus vi squared. 1/2 times our mass times we group our final velocity squared, 30 squared, minus initial velocity squared, 25 squared. When we multiply this, we get 165,000 joules. Now, a good thing to do is to try it with the other formulas. And so for, of course, when we use the work energy theorem, it does not only work with this equation that we used. We could have also used 1/2 mvf squared minus 1/2 mvi squared. However you want to use it. If you remember it more like this, then you can go ahead, because on your exams you will only be given this formula here. That's all you will be given. So it's up to you which one you think might be easier to remember to use. But if you were to use this formula, you would still get the same answer.